structure and bonding. So structure and bonding is a topic in chemistry form 2 that some students tend to find challenging. But I want to assure you this, if you pay attention to the videos that I'll be posting, you're going to excel in this. So stay tuned. Now, our first step is we are going to define what the terms structure and bonding mean. So structure involves the arrangement of atoms to form a molecule or a compound. So in short, it involves understanding how the atoms are connected with one another, leading to the formation of a molecule or compound and such. When it comes to bonding, bonding simply refers to the forces that hold these atoms together in an element, molecule or compound. Now I'm going to mention 3 of these forces which are also called bonds. We have ionic bonds, we also have covalent bonds, and lastly we have metallic bonds. Now let's start with the first one, ionic bonds. Ionic bonds are present in ionic compounds. What is an ionic compound? An ionic compound is formed when you have a metal reacting with a non-metal. So the compound that is formed from this reaction will have ionic bonds. Next one, covalent bonds. Covalent bonds are present in a compound that is formed from a reaction of non-metals. When non-metals react with one another, they lead to the formation of a compound that has covalent bonds. And lastly, metallic bonds. Okay, metallic bonds are the easiest of all. These are simply found in metals. So if you have a metal, sodium, lithium, potassium, calcium, magnesium, these are going to have metallic bonds. Now in our video today, we are going to discuss ionic bonds. What are ionic bonds? How are ionic bonds formed? What are the properties of ionic compounds? Let's dive in. Now the first one, ionic bonds. What are ionic bonds? Now ionic bonds are electrostatic forces that are present between ions that have opposite charges. Okay, that's quite a mouthful. Let's break it down. Now when you have a metal reacting with a non-metal, such as in this case, what you're simply going to form is a compound that is referred to as an ionic compound. Now this compound is going to have ionic bonds. So metal, non-metal, voila, ionic compound. Now I want to mention this. If, for example, you have a metal, such as in the case of sodium, reacting with a non-metal, chlorine, reaction of sodium metal with chlorine gas, you're going to end up having a compound called sodium chloride. Now, sodium chloride is going to have characteristics that are just unique to itself and so very different from its parent elements, and that is sodium and chlorine. Now, sodium chloride in this case is going to be an ionic compound. The bonds or the forces that are going to be holding the particles within sodium chloride are known as ionic bonds. Now coming back to my definition, where I had talked about ionic bond being electrostatic forces holding ions together. So what are ions? Now ions are formed when an atom either loses or gains electrons. Let's pause there. Why does an atom lose or gain electron in the first place? Now there's a rule in chemistry called the octet rule. The octet rule, simply put, states that a lot of atoms are unstable. And the reason why they are unstable is because they don't have full energy levels. Now we know that electrons are arranged in these energy levels. Now you find that if you have an atom that doesn't have full energy levels, then that atom is said to be unstable. So what does an atom that is unstable seek to do? It seeks to gain stability. How does it gain stability? By either gaining or losing electrons. Now in case you're wondering, okay, I need more on this, I need to find out more, what are energy levels, what are electrons and so on, then be sure to check out my video on structure of the atom. Now let's continue. When an atom gains or loses electrons, it forms an ion. So what happens is that when an atom loses an electron, it forms a positively charged particle. When it gains an electron, it forms a negatively charged particle. Now let me give an example. I'll be using the example of table salt, which is sodium chloride. Now sodium chloride is formed from the reaction of sodium metal and chlorine gas. Let's start with sodium. Sodium is a metal that has the atomic number of 11. Atomic number simply refers to the number of protons. So this means that sodium atom has 11 protons. How many electrons will the sodium atom have? 11 electrons. And the reason for this is because when you have an atom, the number of protons is always equal to the number of electrons. 11 protons equals 11 electrons. Now, I want us to put these electrons into their respective energy levels. So 2 for the first energy level. Remember, the first energy level can only take a maximum of 2. So 2 goes into the first energy level. The second energy level can take a maximum of 8. So to work 8 hapo, how many electrons are we remaining with? 1. So the 1 electron remaining goes into the outermost energy level. And we have an electronic configuration of 2, 8, 1. So from this, we are going to find out that sodium has 1 valence electron. Now, what do I mean by a valence electron? When it comes to electrons, we have 2 groups of electrons. We have co-electrons, we also have valence electrons. Now, valence electrons are the electrons that are found in the outermost energy level of an atom. Now, these are the most important electrons because they determine the chemical properties of the element. And these are the ones that participate in chemical reactions. In the case of sodium, it only has 1 valence electron. Now, the co-electrons are the ones that are found on the innermost energy levels. Now, coming back to our sodium atom, sodium has 1 valence electron. So let's see, sodium atom needs to gain stability. So what will it do? It needs to have a full energy level, that is 8 electrons in its outermost energy level. As of now, we only have 1. Now, what sodium atom can do is that it can lose its single valence electron. And that is what sodium atom does. It loses its valence electrons in order to become stable. And by losing its electron, it forms an ion. Now pause. Some of you might be wondering, why couldn't sodium just gain 7 electrons to form 288? Okay, theoretically that is possible, but it requires a lot of energy from sodium to gain 7 more electrons than simply losing 1. So that is what sodium does. It loses its single valence electrons and voila, it has now become stable by having an electron configuration of 2, 8. Yes! Now I want you to look at this. Work it out. How many electrons are left in the sodium? We've lost 1, so we are remaining with 10. What about the number of protons? The number of protons remains the same. It's very rare for the number of protons to change. So we are going to have 11 protons still, but the number of electrons has dropped to 10. So protons are particles that are positively charged. Electrons, on the other hand, are negatively charged. If we have plus 11 and minus 10, what is the overall charge of this ion? It's going to be plus 1. And that is the reason why the sodium ion usually has a positive charge of 1, because it has lost a single electron. Now, when it comes to atoms, atoms are neutral. And the reason why they are neutral is because the positive charge of protons is always cancelled out by the negative charge of electrons. So, neutral. But when it comes to ions, ions will always have a charge, either positive or negative. And the reason is because formation of ions involves either the loss or gain of electrons. Now, the ion that is formed in this case is referred to as a cation. What is a cation? A cation is simply a positively charged ion, such as in the case of sodium. Now let's move to the other side, chlorine. What is the atomic number of chlorine? 17. So 17 protons means we have 17 electrons in the chlorine atom. So what is the charge of this atom? It's 0. It has no charge because 17 protons equals 17 electrons and therefore no charge. When it comes to the electronic arrangement of chlorine atoms, this is the way it goes. 2 in the first one, 8, and then how many are we remaining with? 7. So if you look at the chlorine atom, again, it is not stable because it does not have a full energy level. Now, for chlorine to gain stability, it needs to gain 1 electron. So by gaining 1 electron, it's going to have a full energy level of 288. Now guys, I'm talking about losing electrons, gaining electrons. I want to make something very clear. These electrons are not just present everywhere. They're just, you know, that is not how it works. So essentially, when I talk about sodium losing an electron, chlorine gaining an electron, I'm talking about transfer of electron. So sodium loses an electron, which it transfers to chlorine, and that is the electron that chlorine gains. So essentially, chlorine gains a single electron to form an electronic configuration of 288, and boom, we have a stable arrangement, an octet configuration. Now, In the case of chlorine, what is the new number of electrons? Remember, chlorine gained a single electron. So the new number of electron is going to be 18. What is the number of protons? The number of protons does not change. It remained 17. So we have 17 protons but 18 electrons. So overall the charge is negative because we have an additional electron. So you'll find that the charge of the chloride ion is always going to be -1. So the ion that is formed in this case is called an anion. So an ion is simply an ion that is negatively charged. By the way, it can be any, it can be that of chloride, fluoride, etc. As long as it's an ion that has a negative charge, then it is termed as an anion. So up to this point, we have the formation of a sodium ion that is positively charged and a chloride ion that is negatively charged. Now we know opposites attract. So the positive ion is going to be attracted towards the negative ion. And this is what we mean when we say an ionic bond is the electrostatic force between two oppositely charged ions. So the type of bond that is present in sodium chloride is ionic bond, where you have a force of attraction between the positively charged ions and the negatively charged ions.